All right, finals are coming up fast, and I know the pressure is real, so let's just dive in and conquer one of the trickiest chapters, right? Sets, relations, and functions. Stick with me, and by the end of this, you're going to walk into that exam feeling a whole lot more confident. Look, if you're feeling kind of swamped by all this material, trust me, that is completely normal. Think of this as your personal power review session. We're going to cut right through the noise and focus on exactly what you need to know to nail this part of the exam.
So here's the game plan. First, we'll nail down the core concepts, the stuff you absolutely have to know. Then we'll put them to the test with a sample problem, the kind you'll actually see. After that, we're going to zero in on the two golden rules for functions. And finally, we'll wrap it all up with the key takeaways for your exam. Sound good? Let's do it. Okay, before we can even think about tackling the tough problems, we got to make sure our tools are sharp, right? So think of these next three definitions as the essential gear in your math toolbox for this chapter.
First up, the set. Super simple, it's just a collection of unique things. And that word, distinct, is the key. You'll never see the same thing listed twice. So in our example here, set A just has the numbers 2, 3, and 4 in it. That's it. Easy. Next, we've got the relation. All a relation is, really, is a rule that connects stuff from one set to another. You take an element from the first set, that's our domain, and you see if the rule links it up with something in the second set, the codomain.
And last, but definitely not least, the function. Now, a function is like a very special, very picky kind of relation. It's got these super strict rules about how it pairs things up, and we're about to get right into those. And trust me, you want to understand this, because functions are everywhere. From coding to science, they're the bedrock.
All right, toolbox is packed, definitions are down. Now let's put it all to work. We're going to tackle a real problem, the kind you could totally see on your final. This is where it all starts to click.
Okay, first, a little warm-up, and it's a classic trick question, so watch out. The question is the set containing the number 2 an element of the set containing 1 and 2? Peep those curly braces, that's your hint.
And the answer is a hard no. Here's why, and you gotta get this. That little symbol asks if an element is in the set. The plain number 2 is an element, for sure. But the set 2, with those braces around it, that's a whole different thing. It's an object in itself. And the set 1, 2 just doesn't have that object in it. I'm telling you, this is a classic exam gotcha, so don't fall for it. Okay, warm-up's over. Let's get to the main event. We've got two sets, A and B, and we have a relation, we'll call it R, that connects an element X from A to an element Y from B, but only if a certain condition is met. The rule is Y divided by X has to be an integer, a whole number.
So, first up is 4 related to 6. In other words, does the element 4 from set A have a connection to the element 6 from set B? All we have to do is test it against our rule. Okay, so we take our y, which is 6, and divide it by our x, which is 4. What's 6 divided by 4? It's 1.5. And since 1.5 is definitely not an integer, the rule is broken. So that means the pair 4, 6 is not part of our relation R. Simple as that.
Awesome. So we know how to check one pair. Now, let's find all of them. The question is, how do we build the entire set that makes up this relation R?
The key here is just to be systematic about it. Let's test every single element in A with every single element in B. We'll start with x equals 2. Is 6 divided by 2 an integer? Yep, it's 3. So 2, 6 is in. How about 8 divided by 2? That's 4, another integer. 2, 8 is in. 10 divided by 2? That's 5. Perfect. 2, 10 makes the cut. Okay, moving on to x equals 3. Is 6 divided by 3 an integer? It's 2. So 3, 6 is in. And last, x equals 4. Is 8 divided by 4 an integer? Yep, it's 2. So we got a match there. So when you put it all together, those are the 5 pairs that make up our whole relation R. And just so we're all on the same page, let's be super clear. The domain, that's our set of inputs, is set A. The codomain, our set of potential outputs, is set B. And this little distinction, it's about to become very important. So, we've done it. We built our relation from scratch. But now we get to the million-dollar question, the one I can almost guarantee you'll see on your exam. Is this relation we just made, R, also a function?
I want you to picture this for a second. Imagine we drew this out, right?
with little arrows going from the numbers in set A over to the numbers in set B. The question is, how would we know just by looking at it if we're dealing with a function or not?
Okay, this right here, this is everything. This is your function checklist. If you take away only one thing from this whole review, let it be this. Rule number 1, every single element in the domain has to be used. No one gets left on the bench. Rule number 2, every element in the domain can only have one arrow coming out of it. Not 0, not 3, not 10. Exactly 1. All right, let's put our relation R through the checklist. First up, rule number 1. Is every element in our domain, set A, actually being used? Well, we have pairs that start with 2, pairs that start with 3, and pairs that start with 4. So, yes, every element is used. R passes the first test with flying colors.
But it's not enough to pass just one. It has to pass both. So, time for rule number 2. Does every single input have only one output? Is there only one arrow leaving each number in our domain?
Let's look at our pairs. Okay, the input 3, it only goes to one place, to 6. And the input 4, it only goes to one place, to 8. Looking good so far. But what about the input 2? Uh-oh, it maps to 6, but it also maps to 8, and it maps to 10. That's 3 different outputs coming from just one input. That's 3 arrows.
And that, my friends, is a massive violation of rule number 2. An input is not allowed to have multiple outputs. So because our element 2 goes to 3 different places, our relation R completely fails the function test. It is 100% not a function.
Okay, let's pull back for a second and boil all this down into a simple, straightforward game plan that you can carry with you right into that exam. So here's what you really need to lock in. First, watch those curly braces. The element X is totally different from the set X. Second, a relation is just a list of pairs that follow some kind of rule. And third, and this is the big one, for any relation to be a function, it has to pass that 2-rule test. Every input gets used, and every input has only one output. That's it. Seriously, you've got this. You know the definitions now, you know how to build a relation, and you know exactly how to check if it's a function. You have the tools you need. So now, go on, open that book, and go crush the next problem. You can do it.